Hi guys, welcome to day 4 of the notes. For today you'll have an assignment on delta math for practice, and what we're going to do today is we're going to identify the 3 different trig functions by their graph and their basic level, and then later we are going to identify the trig equations of graphs using their midline and amplitude. So we're going to make some changes to them. So this first page of notes is the basic trig graphs for sine, cosine, and tangent, and their negative components. So let's look at this first one, the y equals sine. So here's the graph of y equals sine x. Now, I gave you the graph from negative 2 pi to 0 to 2 pi. So there's my y-axis and there's my x-axis. I'm really mainly concerned in this event that we're doing now with a full complete cycle. We learned about one complete cycle in our last lesson of the graph from 0 to somewhere, okay? The basic trig graphs, or the introduction to the sine graph, goes from 0 to 2 pi with pi in the middle. Each one of the trig graphs has 5 important parts, okay? The first important part of the trig graph is where it meets the y-axis, or the y-intercept. The sine graph meets the has a y-intercept at its midline, okay? In this case, it's 0 because it's the basic graph, but it's also the midline because remember, I determine a midline of a graph if I draw a line along all the minimum parts of the graph, and I draw a line across all the maximum parts of the graph, and then I split it. So this goes one up to here and another one halfway. This is the midline, and in this case, the midline is y equals 0. Okay? This sine graph starts on the midline. All sine graphs start on the midline, wherever the midline may be. And they have these 5 important values. A sine graph that's positive will start at the midline. It'll go up to its maximum at the first stop, down to the x-axis, then down to its minimum, and then back up to the same place where it started at the midline, okay? So the y-intercept is at the midline. It has an S shape, and it is going up. What do I mean by go up? From its first point on the y-intercept, it goes up. Okay, so that's a positive sine graph. All right, right below this in the notes is a negative sine graph. Okay, so a negative sine graph, let's find the midline. That's what we should do with all of these. To find the midline, I draw across all the maximums. I draw a line across all the minimum or low values to enclose the wave. Okay, the midline is halfway between them. So up 1 is half because 1 down from the top. So my midline on this one is this dotted line. And in this case, it goes through y equals 0, so the midline has an equation y equals 0. This graph has a y-intercept at 0, okay? So we're talking about the graph of y equals negative sine x now, and it has a y-intercept of the midline, okay? From this y-intercept, we have the 5 key points. There's the first one. It goes down to the next one. So it goes down from the midline, okay? To this, that goes back up to the x-axis, goes to the maximum, and then ends at 2 pi. So it has a y-intercept at the midline, it goes down, and it is again the S shape. And what I mean by an S shape, it goes back and forth. The top one goes up and down and around, okay? So in the negative sine x graph, so see how it goes down, then back up and back to the midline, okay, from 0 to 2 pi. Let's do the same study with the graph of y equals cosine x, okay? So in this case, we have a graph of y equals the positive cosine x because we assume it's positive. And again, I'm worried about the portion of the graph from the y-axis starting here, finishing a full cycle, okay? All right, so I'm going from 0 to 2 pi. So this creates a cup shape, okay? let's find out where the midline is and where this graph starts. So I'm going to enclose the graph from the top parts, draw a line straight across the tops, and draw a line straight across the minimum values or the bottom. Halfway between is the midline. That's this line here. And this midline for this graph has an equation of y equals 0 for the midline. Looking where our y-intercept is for this cosine graph, it's up here at a maximum value. So my y-intercept is at the maximum. Okay? Unlike sine, who started off in this middle part here, we're starting off at the top, and from the top we're going down. And then we're going to go down, goes down from that starting point here, and it has a C or cup shape, okay? And the cup opens up, all right? It doesn't have this like wavy S pattern. It has just a cup pattern or C pattern, okay? So that is the graph of y equals positive cosine x. Right below that, we have a graph of the y equals negative cosine x, okay? So this is the positive one up here. And down here we have a graph of negative cosine x. And again, the basic graphs start at the y-intercept, which is here, and you go until you complete one full cycle. And when I finish the cycle, I started here and I ended here at 2 pi. That creates an upside down cup. So putting this negative in front just flips the cup from right side up to right side down, or an empty upside down cup. But let's see the midline on this one. So we always want to find the midline so we know if it's starting at the midline, the maximum, or the minimum. The midline here on this basic negative cosine graph is the x-axis, or y equals 0 is the midline. Okay. This graph, there's my y-axis right here. It is starting at the minimum. So my y-intercept is at the minimum. Okay. And from 0, this minimum, it's going in the up direction. It's going up. So it goes up from there. And it has a cup shape and it opens down. Okay, so this is the graph of negative cosine x. It opens down. And this is the graph of the positive cosine, and this opens up. So we can say that cup shape, and we could also say that it opens up. All right, so that's the graph of positive and negative cosine, the basic graphs. Okay. Down here at the bottom, we're not going to do a ton of this with the tangent of x, but I wanted you to see what it looks like. I think it might pop up in your Delta Math. But tangent graphs, this is the graph down here of the positive tangent. Now, tangent graphs have a couple of key features. It has what's called an asymptote. You've heard this before. It has asymptotes, and usually more than one. So that's a good indicator that you're in a tangent graph. What does an asymptote mean? It means a place where there is no value. There is a hole in the graph. There's one here. These are all asymptotes, these dotted lines. The graph does not exist. We don't have a cup. We don't have a S shape that hovers around the x-axis or anything. The other way you can identify that it's a tangent graph is if you put your pen on any part of the graph from left to right, see what happens. So I'm going like this. And this graph opens up. And if I do another one from left to right, this graph opens up. All right, so when you have the asymptotes, and when these lines go up each time, you have a positive tangent of x graph, okay? And we call that increasing, okay? So if your graph is, all these lines are heading up, it's positive and it's increasing and it has these asymptotes in it. That's how to recognize a positive tangent. So if a positive tangent has always going up lines, right? A negative tangent graph would probably have always going down lines, like this example here. So we still have the asymptotes, right? They all exist. And if I put my pen from left to right on any of these lines, let's pick this one, and follow it, it goes down from left to right. So these lines go down. That one goes down, that one goes down, and this repeats. When a graph from left to right goes down, it's decreasing. Okay? And we also still have those asymptotes. All right? So the graph of y equals a negative tangent of x in its basic form goes down, and it has the asymptotes in it. Let's go to the next level for this. We're going to look at these pictures of graphs on the next page, and we're going to determine, is it a positive or negative graph, and is it sine, cosine, or tangent? That's all we're going to do at this point, and then we're going to go to another level on the next page. So, how do we know what kind of graph this is? Okay, so the first thing we learned about the graphs on the other page is we need to know where it starts on the y-axis. But to do that, I need to know where the midline is. So I draw a line across all my maximum values, across the tops. I'm going to draw a line across all the bottoms. And I'm going to count the squares in between. It's easiest to count on the y-axis here. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's 10 from top to bottom. Half of 10 is 5, so I go up 5 for the midline. 1, 2, 3, 4, 5. And in this case, the midline goes down our x-axis and has a value of y equals 0 for the midline. Now, the next question we need to ask is, what does one cycle of our graph look like here? So, one cycle of our graph, it's not a cup shape. It looks like it's got the S shape. It's just stretched out. There's one cycle of the graph. Okay? Now, that looks like an S shape to me, and it starts at the midline. Okay? So, it starts at midline, and it has an S shape. And from its starting point, it goes up. So it goes up. So that means we have the graph of a positive sign. And that's how we identify the trig function of the graph. All right. Let's go to this next one here. Now, first thing we need to do is find the midline. I'm going to draw a line across all the maximum values. I'm going to draw a line across all the minimum values. And I'm going to find halfway between the top and the bottom. So 1, 2, and halfway between 1 and 2 is this -1 here. So the midline of this graph is at this y value here on the y-axis, -1. So this graph was a little bit below the x-axis. Okay? So the midline is y equals -1. Now, where does one cycle of the graph start and finish? So I'm looking right here, and the start of the graph in one complete cycle is a cup shape. All right? It starts at the maximum, and it's a cup shape. It's going to tell us it's a cosine. Okay? So that's our first thing. It's a cosine graph. We also, from our first point here, it goes down. Because it's a cup and it goes down from its first point, it is a positive cosine graph. Right? So it has a positive value and it's a cosine graph. Let's do the next one here. Very different looking graph here. I can see that there are these vertical asymptotes, so I already know I'm dealing with a tangent graph of some kind. Okay? Now, the other thing I need to do is find a nice part of the curve, and I need to put my pen on it on the left side and follow it up. Now, it ends in the up direction, so when a tangent graph is increasing and ends in the up direction, it's a positive tangent graph. So that's all we wanted to do, to recognize with that. Let's go to D. The next one here at D, let's go ahead and enclose our graph on top and bottom. We want to see where the midline is. If I don't know where the midline is, I don't know if it starts on the midline, the maximum, or the minimum, and that's very important. So, from the bottom of this, I count 1, 2, 3, 4, 5, 6, 7, 8. Half of 8 is 4. 1, 2, 3, 4. So the middle from top to bottom is here, and it's right on the x-axis. The y value is 0, so it has the equation y equals 0 for the midline. Where does one cycle of our graph start? So I'm looking at where does it start on the x-axis. It starts here, and this is a maximum on the graph, and it goes down and back up to complete one cycle. All right, so when it starts at a maximum and goes down, I know that I have a positive cosine graph. Okay. Let's go ahead and look at another wavy graph here. Step 1 to determining what it is, find your midline. There's my minimums. There's a line across all my maximums. I'm going to count from bottom to top. 1, 2, 3, 4, 5, 6. So it's 6 units all the way, so halfway would be 3. 1, 2, 3. So this is my midline of this graph. What is the y value for my midline? It's 4. So my equation of the midline is y equals 4. Now let's figure out where does our graph start on the y-axis. On the y-axis it starts here, and that looks like a maximum, and it goes down from there. Already have enough information, but let's trace out one cycle of it. This is a cup shape, so we know it's cosine, and the cup is opened up, so I know that this is a positive cosine graph. See, these aren't too bad. All right, this has a lot of waves to it. So this has been adjusted with some other, parts of the equations that we're going to get to in the future lessons. How do they make that wave tighter? But we're going to follow the same procedure. Is this a cosine? Is it a sine? Is it a tangent? I already know it's not a tangent because there's no asymptote. So let's go ahead and see what else is going on here. Find your midline. So there's my tops. There's my bottoms. Halfway between, I'm going to count from here. 1, 2, 3, 4, 5, 6, 7, 8, 8. 1, 2, 3, 9, 8, 7, 6, 5. That's 4. Okay, here's my midline. The lines are a little hard to see. All right, so this is at 1, 2, 3, 4, negative 5. All right, so my midline's at negative 5. Where does my graph start on the y-axis? Here's my y-axis. It starts right here and then goes up. Let's trace out one thing. Now, I know this is more than a cup because if I do just a cup here, I would have this part of the graph that I didn't include in the first pattern. So this is going to go up, down, and back up. That gives it a really skinny, squishy S shape. So I know that that's a sine graph. Now, is it a positive sine graph or a negative sine graph? When it starts at its midline and goes up, it's a positive sine graph. All right, couple more to do here. This last one, immediately when you see this, you should notice that it has these vertical asymptotes in it. So you already know that it's a tangent graph. Okay? Next thing we need to know about it, is it increasing or decreasing? So just from left to right, find one of these nice curves, put your pen on it, and follow it. It ends in the up direction. So you know that when a tangent is increasing, it's a positive tangent graph. And the last example we have here is another wave. When we have the waves, right, it keeps repeating pattern, you always have to find the midline to know what's going on. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's 10 all the way, so I need to go up 5. 1, 2, 3, 4, 5. So this is the midline here. And that has a value of 1, 2. The y value is 2. So the midline is at y equals 2. All right. Where does the graph start on the y-axis? Here's my y-axis. My graph intersects right there and then goes up. It's not a cup shape because it goes down again here. And that is one complete cycle. That's an S shape. So we know that it's a sine graph, and it starts at the midline and goes up, so it's a positive sine graph. So that's pretty cool. We got a bunch of examples of that. Now, where are we headed with all this? We're going to add the amplitude to some of these. Sorry, I just hit the thing. And actually, none of our first examples have amplitude in them. So let's just, oh, yes, they do. Okay. In this first example here, here's a recap of what we just did. If a graph starts at the top or the max, it's a positive cosine. If it starts at the middle or midline and goes up, it's a positive sine. If it starts at the bottom or minimum, it's a negative cosine. See the upside down cup? Empty cups are negative. Start at the middle and goes down is a negative sign. So that recaps that. So how do we determine the equations, right? Here's the steps. The first thing we do is determine the midline. This is the D value in our equation. We determine the amplitude second, and then we have to worry about if it's negative or positive, okay? Put the values into the equation, and these are the equations here. Y equals A sine little b x plus d, or y equals a cosine bx plus d. A is the amplitude, B is the frequency, and today we're just going to have a frequency of 1, and D is the midline. Okay? And A's are the amplitude. So let's get right into that. Okay? We're going to just have B values of 1 today, but we are going to have amplitudes and midlines. So our job here in this first example is we are having to write the equation of the dotted line. Now, I'm going to worry about it from 0 out, okay? And so 0 to 2 pi is what I'm worried about today. I can see that this graph goes like that. It's an S shape, so I know it's sine, so I've confirmed that. They also told us today that today's notes would only have a frequency of 1. Remember, frequency is how many complete curves between 0 and 2 pi. This is our original curve, so I know it's sine. But we're asked to give the equation of this dotted line up here. How do I do that? The first thing I do in the dotted graph, I am going to have to find the midline. So I'm going to draw my line across the tops of it, or the maximums. I'm going to draw my line across the minimums to enclose the dotted line graph top to bottom. Count the squares and find the midline. 1, 2, 3, 4. Half of 4 is 2. So 2 from the top or 2 from the bottom is my midline. My midline meets the y-axis at 3. So the equation of my midline is y equals 3. Okay? So my midline is y equals 3. It's hard for you to see. The midline is y equals 3. What do I do with the 3? It goes here, a positive 3. Now, in these examples of the equations up top, this is your amplitude, this is your frequency, and this is D, your midline. All right, so we found that part of the equation. All we have left to do is find the amplitude. Now remember, the amplitude is the distance from the midline to the top and the midline to the bottom. So let's find that. So I'm just going to pick a point on the midline that has a maximum above it. So here's a maximum value, and here's its corresponding point on the midline. What is the distance between these? It's 1, 2. Let's double check in another point on the graph. Here's a minimum. What is the distance from the minimum to the midline? 1, 2. Okay? So the midline, the amplitude is 2, because amplitude is defined by the distance between the midline and the max, or the midline and the minimum. So my amplitude is 2. And that's it. Let's do a couple more examples. This is going to be exactly what you see on Delta Math in your assignment. Let's do one here. They're already telling us it's cosine, so I'm expecting a cup shape, right? So here is from 0, here's 2 pi, right? We're worried about that. So 2 pi to 0, 0 to 2 pi. I kind of missed that with this highlighter. Okay, 0 to 2 pi. That makes a cup shape, so I've confirmed that it's a cosine graph. Now, it starts at a maximum and goes down, so it's a positive cosine graph. Let's focus on the dotted line graph now. I looked at the solid line. the dotted line graph, the lower bound for the dotted line. The dotted line graph is actually made by changes to the equation of the original. Okay? All right. So I've enclosed my dotted line graph, and I probably shouldn't have highlighted that. I'll have to do a different color. But where does the graph start? It starts here on the y-intercept at its maximum, and it goes down. I'm going to use yellow to trace this. So where's my first complete cosine graph? It's a cup, so it goes down and up and makes the cup shape. Okay. Now, I need the midline. So counting from the bottom to the top, 1, 2, 3, 4. Half of 4 is 2, so going up 1, 2, my midline is here. My midline has the equation. The y value of the midline is 2, so my equation of my midline is y equals 2. So my midline is y equals 2. So this 2 for the midline goes in this part of the equation. Okay, this is amplitude, this is frequency, this is midline. The frequency is 1. Frequency means how many complete cycles from 0 to 2 pi. We knew that all of these are going to be 1, but this is 1 complete cosine cup because here's 2 pi. And we have 1 full cycle. That's why this is 1. Let's figure out our amplitude. Our amplitude is the distance from the midline to a maximum. Let's pick this one. Here's a point on the midline, and here's a point on the maximum directly above it. What is this distance? 1, 2. So the amplitude is 2. We could also double check. We could pick a point on the midline, and here's a minimum. That's also 2. So we have 2 ways to do the amplitude. The amplitude is 2. And that's where the 2 goes in the equation. One more to do. All right. This one's different. So here's our dotted line up here. Let's go right to that dotted line. I'm going to enclose it at the bottom and the top. To find the midline, it's halfway between, so it's just 2 units tall, so half of 2 is 1, so you go 1 from either side, and my midline is here. My midline has the equation y equals, the y value of my dotted line is 3, so my midline is y equals 3, so 3 goes in that spot. My dotted line graph from 0 to 2 pi looks like that. It's an S shape, so I've confirmed the sign. And it has a frequency of 1 because I have 1 complete cycle between 0 and 2 pi. All right, what is the amplitude? The amplitude is the distance from the midline to the top. That's this part, that's 1, or the midline to the bottom. So that's also 1. So this has an amplitude of 1, but something we want to consider here. Here's the graph of a positive sign. It starts at the midline and goes up. Our graph up here starts at the midline and it went down from the midline. So it is a negative sign graph. So the negative goes out there with the amplitude. So that would be the equation y equals -1 sine of 1x plus 3. And that's how we get the equations of graphs using amplitude and midline and identifying what kind of graph it is. So your work, you'll have a homework assignment on delta math. And I'm not sure if you have any negative ones on this one, but I wanted to put it out there so that you could get an introduction to it. So good luck on that. Email me with any questions. Have a good day.